This was the homework for 13.3. The first, questions. All you have to do is convert them. It's a degree problem, you're gonna convert it to radians. How do you do that? You take the question, and you multiply it by, since you wanna get rid of the degree, you're gonna multiply by pi over 180. The bubbles cancel. And then all you really have to do, if you have a calculator, is divide this and convert it to a fraction. And you get negative 5 pi over 3. Questions on those? So for number 7, all of these you're going to multiply by pi over 180. So 150 degrees times pi over 180.
Is it always over 180 degrees?
If it's degree, it's pi over 180.
So, okay.
Okay, and this one you should get 5/6. Number 8, you're going to multiply negative 90 degrees by pi over 180. You should get negative pi over 2. And I have it right here for you.
Wait, is that 190?
No, you know what? That's not. Somebody last hour had asked me. It's just negative. It's negative 1 times 90, I guess. That's what they were asking. It's not negative 190. It's just negative 90. So in other words, what I did was I canceled the bubbles. I crossed out the zeros, and 9 goes into 18 2 times. So the answer is negative pi over 2. Number 9, you're going to have negative 60 degrees. You're going to multiply by pi over 180. So the bubbles cancel. 60 goes into 180 3 times. So your answer is negative pi over 3. This one is 160 times pi over 180. You should get 8 pi over 9. And number 11, 20 times pi over 180 is pi over 9. Questions? Yes.
What was the answer to 6?
Negative 5 pi over 3.
Where did you get the 8 from number 10?
Number 10, where do you get 8?
It's like 8
Okay, you have 160. Ignore this answer.
Oh, never
160.
mind, I got it.
2 goes into both of these. You get 8 ninths. Yes.
What happens if we left them as a decimal?
Leave them as a fraction.
Okay.
Don't turn them into a decimal. Okay, the next set. How do you go from radians to degrees? Well, if pi is equal to 180 degrees, and if you want to get rid of the pi, you're going to take these problems, so 3 pi, you're going to multiply it by 180 over pi. And here the pi's cancel, so 3 times 180 is 540. For number 13, you're going to take 11 pi over 10. You're going to multiply it by 180 over pi. These cancel. And then this is what I did. The zeros cancel, and 11 times 18 is 198. For 14, negative 2 pi over 3. You're going to multiply it by 180 over pi. These cancels. 3 goes into 180 60 times, and negative 2 times 60 is negative 120. Put the degree in. Now, 15, I believe I asked you to change it to negative 3 radians, right? Did I ask you to change, or negative 3 pi radians, right? Okay, now I want to go over this. We didn't have time to do this on Tuesday. I want to talk about the difference between this, and there's another name. In other words, this is 90 degrees, or it's pi over 2. This is 0 degrees, or it's 2 pi radians. This is 270 degrees, be careful, or 3 pi over 2 radians. Now, if pi equals if pi radians is equal to 180 degrees, can anyone think of another way you can write this answer in radians? What's another name for pi?
3.14.
So there, you could write pi is also 3.14 radians. How would you change this answer into radians? You would take 3.14 and divide it by 2, because 3.14 is pi, and you get 1.57. So you could also call this 1.57 radians. So in other words, 3.14 radians is equivalent to how many degrees? 180 degrees. So if this problem, -3, if it said -3 radians versus -3 pi radians, how would you do them? If the pi is there, you're going to multiply this by 180 over pi, because you want those to cancel. If the pi is not there, you're going to multiply it by 180 degrees over 3.14. Does that make sense?
Do you say radians next to it? So that,
Yeah, I would put the word radians next to it so it'll remind you to cancel it. So for that question, the pi wasn't there, so technically this is the correct answer. But since I didn't have time to explain to you, if pi is not there, you can convert that into radians by multiplying by 3.14. Yes?
is there a specific reason they have two essentially with the same problem?
Yeah, because pi is equivalent to 3.14.
Right.
So it's just another way of expressing, see, this is another way, pi is another way to say 3.14.
Right.
But if you say 3.14 pi radians, that's 3.14 times 3.14. Okay? So for this one, I wrote -3 pi versus -3 radians. Those are two different problems. For the one that they gave you, -3 radians, you would multiply this by 180 over 3.14 radians. These cancel, and if you just use your calculator, I would expect you to use your calculator, you're gonna multiply -3 times 180 and divide that by 3.14. The answer's about negative, you get a decimal here, but it's about -172 degrees. Same with this one. 1.57 radians. Pi is not here, so we're not going to do 180 over pi. We're going to just change the pi to 3.14. So the radians cancel, and if you multiply 1.57 times 180, divide that by 3.14, you should get 90 degrees. And the last one. 471 times 180 over 3.14. The radians cancel, and your answer, if you multiply across and divide, you should get 270. Okay, now, these next ones, I'm gonna re-explain, reteach them, and show you how to do them. So, what we did was, we took the unit circle, and we divided up into degrees. Let's do it really fast. 0, 90, 360, oh, not 360, what's wrong with me? My brain's going faster. 270 and now 360. Okay, what's halfway from 90? 45, so each of these are 45. 45, 45, you get 90. Add 45 to 90, what do you get?
135.
Add 45, you get 180. Add 45,
2.
add 45, add 45.
15.
The more you do this, the better you will get at it. Now, can you divide this into the other angles? What's this? 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, and 330. So, what we did was we talked about if you have a 30-degree angle, here's a 30-degree angle. This measures 30 degrees, right? we talked about what sine, cosine, and tangent is. Sine is a ratio. It compares the side opposite over the hypotenuse. Cosine is a ratio. It compares adjacent to hypotenuse, and tangent is a ratio. It compares the side opposite over the adjacent. Well, if you have a 30-degree angle, you learned in geometry that the side opposite the 30 is a 1. The hypotenuse is a 2, and the side opposite the 60 is a root 3. So if I say what's the sine of 30, it's 1 over 2. I say what's the cosine of 30, you say root 3 over 2. Now what happens if we are a 150-degree angle? Well, then what you do is you use this triangle here. This is a 30-degree angle, but it's in quadrant 2. And so you would call this 1, this negative root 3, and this 2. So what's the sine of 150 degrees? It'd be 1/2. What's the cosine of 150? It'd be negative root 3 over 2. And tangent would be 1 over negative root 3. What if you were a 30-degree angle off of the x-axis down here? In other words, a 210-degree angle. A 210-degree angle, here's your 210-degree angle. This angle is still 30, but it's in quadrant. This is from here to here is 210. You're in quadrant 3, and in quadrant 3, the x value and the y value are both negative. So I use a -1 here, and a negative root 3, and a positive 2. By the way, the radius is always positive. So when I say, hey, what's the sine of 210 degrees? I'm going to use this 30-degree angle and say -1/2. Cosine would be negative root 3 over 2, and tangent would be -1 over negative root 3. Now what happens when you land here, 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 or here? Well, that's when you use the ordered pairs, 0, 1, -1, 0, 0, -1, and 1, 0. So when we talk about the sine of 90 degrees, you have to know that sine is y over r. So at 90, the y value is 1, 1 over 1 is 1. Cosine of 90, cosine is x over r. The x value is 0, 0 over 1 is 0. And tangent of 90, tangent is y over x. And that's going to be 1 over 0 is undefined. Okay? So now, how does this tie in to the radian stuff? Well, what we did now is we took our circle and we divided it up in radians. So we said, well, 0, here's pi. Pi was 180. So then we said, okay, this is a half of pi, because from here to here is 1 pi. So this is a half, a whole. This is 1 1/2, and this is 2. Okay? So now if this is a half, what's half of a half? A quarter. So if this is 1/4, 2 quarters, we have 3 quarters. We have 4 quarters, 4/4. Then we have 5/4. We have 6/4. 6/4 reduces to 3/2. And we have 7/4. And we have 8/4. 8/4 is 2 pi. Then if we took from here to here, which is pi, and we divided it up into 6 regions, this is going to be 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6, 8/6, 9/6, 10/6, and 11/6. And then of course 12/6. Now, out of these, some of them can be reduced. This one can be reduced as 1/3, or pi over 3. This one can be 2/3. This one can be 4/3. This one can be 5/3. And back to 2 pi. Now, what did we say this angle was right here in degrees? What was that first angle we talked about?
30.
That's a 30. What did we say this was? 45. And what did we say this was? Can anyone quickly come up with a way we can all remember pi over 6, pi over 4, and pi over 3? What's a shortcut way we can remember this? They see it? The 4 and the 45, okay?
And then the 3 and the 6 are opposite.
And these are opposite, and that's exactly how I remember it. Now watch this, this is kind of interesting. See how from here to here, it's a from here to here, we're talking a 60-degree angle. Now, when we measure angles, we always measure them off the x-axis. So check this out. I'm going to circle all of the 30 degrees off of the x-axis. Just look at all the circled ones. What do you notice about all the circled angles off of the x-axis?
They're all over 6.
They're all with a 6. So when we say 7 pi over 6, you're going to get used to saying, oh my God, that's in quadrant 3. You've got to, right away, when you hear the 6, think of 30 off of the x-axis. When you see 11 pi over 6, think of 30 off of the x-axis in quadrant 4. So when you name your triangle, you're going to know if it has a 6 in the bottom, we're talking about the 30. So you're going to call this side 1, 2, negative root 3. If it's in quadrant 3, this is going to be negative 1, this is going to be negative root 3 and 2. And if you're in quadrant 4, this is going to be a 1, I'm sorry, this is going to be a negative 1, this is going to be a positive root 3, and then 2. So, then, now check out the 30, the 60s. Check this out. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. What do you notice about that? So I'm gonna do it here on a separate sheet because it's kind of messy. So back to my circle. This was pi over 3. What was that? 60. Then we had this one. This was 2 pi over 3. Then we had what? We had 4 pi over 3. From here to here is 4 pi over 3. And what's the other one? Looks like a bow tie. 5 pi over 3. These are all the 60s off the x-axis. Do you see it? The ones that have a 3 in the bottom are 60 degrees off the x-axis. Now, why do we need to know this? Well, because for 18, it says pi over 6. So you know you're in quadrant 1. You draw your triangle. It's a 30-degree angle. You've got to know a 30-degree angle. The side opposite is a positive 1. The hypotenuse is double that number, and the adjacent is root 3. So the sine of a 30 degree is opposite over hypotenuse, 1 to 2. Cosine would be root 3 over 2, and I didn't put tangent, but you should do that one as well. Tangent would be 1 over root 3. Next one. We have pi over 3. That's a 60 degree in quadrant 1. So you got to know 60, so the side opposite is root 3, 1 and 2. So the sine of pi over 3 is root 3 over 2. Cosine is 1/2, tangent root 3 over 1. Next one, pi over 2. Here's pi over 2. Now, if it is not an angle within the quadrants, if it's on an axis, you need to jump to these ratios. Sine, think of y over r. Y value is 1, 1 over 1 is 1. The cosine is x over r, 0 over 1 is 0. And tangent is y over x, so that's undefined. Next one, 21. It says negative pi over 4. So we're going to go backwards 45 degrees. Remember I told you if it has a 4 in the bottom, think of 45. In a 45-degree triangle, you should automatically you think of this triangle, the 45. In 45, our sides are 1, 1, root 2. But when it said negative 45 says, hey, you're in quadrant 4. And in quadrant 4, the x value is positive 1, but the y value is negative 1, because you're going right and down. The hypotenuse is always positive. So when I say what's the sign of negative pi over 4, it's going to be negative 1 over root 2. The cosine of negative pi over 4, sorry guys, is 1 over root 2. And tangent would be negative 1 over 1. Next one. 2/3 pi. 2/3 is less than, remember, from here to here is pi. So 2/3 has to be in quadrant 2. It's 2/3, it's not more than 1. So you're in quadrant 2. So remember what I said, if it has a 3 in the bottom, it's a 60-degree angle. So in quadrant 2, the x value is negative and the y value is positive. So that's why I named this side negative 1 and this root 3. So now, what's the sine of 2 pi over 3? It'd be root 3 over 2. Cosine would be negative 1/2, and tangent would be root 3 over negative 1. 23. We are at negative pi over 2 radians. And again, negative pi over 2 is on the y-axis. So when you're on the y-axis, you're going to use the ordered pair 0, negative 1 here for that point. So sine is the y value. Here's the y value over r, so negative 1 over 1, which is negative 1. Cosine would be 0 over 1, which is 0, and tangent would be negative 1 over 0, which is undefined. 24. It says 5 pi over 4. 5 pi over 4. So that tells me this is 1 1/4 pi. So I know I'm past quadrant 2. I'm in somewhere in quadrant 3. And I say, oh, it's the one with the 4 in it. 4 in the denominator. So this is a 45er. And you should know that in a 45, these both sides are negative 1 and this is root 2. So the sine of 5 pi over 4 is going to be opposite over hypotenuse, negative 1 over root 2. The cosine of 5 pi over 4 is also negative 1 over root 2 because it's adjacent. And tangent of 5 pi over 4 is opposite over adjacent, and the negative 1s cancel out, so your answer is just positive 1. Questions? And the last one, 7 pi over 6. So where is 7 pi over 6? So I know that that's top heavy. So it's bigger, it's 1 1/6 pi. Well, 1 1/6 pi, well, if from here to here is pi, it's got to be somewhere in this quadrant. And it's the one with the 6 in it. What did we say the 6 was?
30.
A 30, good. So now this is going to be negative 1. This is going to be negative root 3. And this is going to be a 2. Remember, your hypotenuse is always positive. It's the x and the y that change positive and negative. So what would be the sine of 7 pi over 6? Well, you're going to use this angle. It'd be negative 1/2. Cosine of 7 pi over 6 would be negative root 3 over 2. And tangent would be negative 1 over negative root 3, or 1 over root 3. Does anyone not get this? Okay, the last 6 problems that we didn't do are very easy. How do you find the arc length? All you do is multiply the central angle. So in this problem, you want to figure out what portion of this circle is this length right here. All you do is multiply the angle, which measures pi over 3, multiply it by the radius. And that's it. That's all you do. So what's pi over 3 times 3? Because 3 is the radius. The 3's cancel and you get pi. Or you could name this as 3.14 units, whatever, however, it would be centimeters. 3.14 centimeters. Number 27, you're gonna take the central angle, 2 pi over 3, and multiply it by 5 meters. Now, I would just leave it as 10 pi over 3, and then it's meters. 28, I wanna know how long it is from here, this is M, this whole thing. Right here, what I wanna know. So I take, they tell me that going, this angle is 11 pi over 6. Multiply that by the radius. And you get, simplified 6 and 9, 3 goes into both of those, so 2/3, so you get 33 over 2. Now, just for fun, what if I would have asked you what this angle is, right here, or this arc, I'm sorry, from here to here? Well, what I would have done, if from here to here is 11 pi over 6,
Get the degree value.
you figure out what's left. If a whole circle is 12 pi over 6, because that's another way for saying 2 pi, what's this right here? Pi over 6. Because 11 pi plus 1 pi is 12 pi. So this angle would be 11 pi over 6, and then you would multiply that by 9. And that would be how big this is if you needed, if they didn't give you that angle. You can figure out what that angle is by subtracting it from 2 pi. But you had to get a common denominator. Next one, these were pretty straightforward. They want to know what A is. This is A from here to here, all this part right here. So if this angle is 4 pi over 3, multiply that by 6 and you get 8 pi.
So, in 28, don't they want the circled part?
Yeah, I just said if they didn't.
Oh, okay,
If they didn't, if they gave you this problem
with just,
and they
They
said they
want
wanted
that.
this side, then you would have to figure out what that angle is.
okay,
Yeah, I just added that,
thank you.
because they didn't do any of those.
Huh.
Number 30, they give you, they want to know this angle right here, or not this angle, this arc, W from here to here. They gave you the they made these easy. The arc, the central angle is 3 pi over 4, multiply that by the radius. 2 goes into 4 2 times, so it's 3 pi over 2. And the last one, where? 31 or 30?
31.
5 pi over 4 is your angle. This is 5 pi over 4. Why is it 4?
Like, no, 35 lines are should 44 times 2.
5 times 11 is 55 over 4.
You don't multiply them. Okay.
Yeah, the bottoms you do. 4 times 1 is 4.
That's okay. I was confused.
Okay. Do you guys get this? Yes.
Can you do 28 again?
28, yes.
Yeah.
Okay. 28, sorry to confuse you. 28, I want to know, I'm going to use my highlighter. They want this measure M, right here. So all you do is take that angle, that central angle, which is 11 pi over 6, and you multiply it by the radius. Now, when you multiply fractions, you know you have to reduce at some point. I look at these two numbers as top and this bottom. I say 3 goes into both of these. 3 goes into 6 2 times, and 3 goes into 9 3 times. And now what's the rule for multiplying fractions? You multiply across, so you get 33 pi over 2 times 1 is 2. Now I had said, what if they gave you this problem and they asked you to figure out what this arc is equal to? Well, they didn't give you the length of this angle. They didn't give you the measure of that angle. So if from here to here is 11 pi over 6, you would have to figure out what that angle is, which would be pi over 6, and then multiply that by 9 to figure out what that is.
Oh, yeah.
That's why I just threw that in. Okay? Does anybody have any questions? Yes.
With the answers, did you want us to keep the pi in it, or did you?
Yeah,
want
I
us
would
to-
keep the pi in it.
Yeah.
Now, in the book, I'm gonna be honest with you, they did not, but I would want you to keep it in there, yes.
For problems like 18 through 25, how do you tell what quadrant the triangle is going to be in again?
How do you tell, the question is, on 18 through which ones?
25.
25. How do you know which quadrant you're in? Well, you have to have some idea of this circle right here,
Oh, okay.
okay?
So-
Now, let's seriously, this is a very important, it's a good question. I want you to think of this. It's kind of like number sense. Okay, from here to here is 1 pi. And all the way around is 2 pi. This is a 1/2 pi. And this is 1.5 pi. Okay, so we broke it up into 4s. Pi over 4. This is 3/4. So you're at 3/4, 4/4. This is 5/4, 6/4, 7/4, and 8/4. And then you had 1/6, 2/6, 3/6, whoops, 3/6, 4/6. I'm just gonna do the fraction, pi's in there. 5/6, 6/6, look, 7/6. See how 7/6? 7/6 is 1 1/6 pi. It's more than 1 pi, so you're in this quadrant. 7/6, then we have 8/6, 9/6, we have 10/6, and 11/6. So you want to think of, like, something like 11/6 is bigger than 1.5, but it's less than 2. Miss Adia? Sure. Thanks, bye. So when they give you 7/6, you gotta think of that 7/6 is a top-heavy fraction. It would convert to 1 1/6. So the 1 tells me I'm bigger than pi. Now, what about 5/6? 5/6 is bottom-heavy. So that means I didn't reach here yet, but I'm bigger than 1/2. 5/6 is bigger than 1/2. But it's not quite a pi. So I know I'm somewhere in quadrant 2. It's a very good question. Did everybody understand that? How do you know what quadrant you're in? You have to have some number sense of from here to here is 1 pi, this is 1.5. So think about the fraction. If it's bottom heavy, you're in quadrant 2. If it's top heavy, you're gonna be, if it's bottom heavy, I should say you're in 1 and 2. If it's bottom heavy, if the bottom number is bigger than the top number, you're in 1 and 2. If it's bigger than 1/2, you're in quadrant 2. Does that help you?
Yeah.
Now, if it's top heavy, you gotta be in 3 and 4. If it's top heavy more than 1.5, 1.5 is right there, then you're in quadrant 4. Hopefully that helps you. Okay, Brett, turn off the camera for a second.
No problem.